Okay, we're going to get started into chapter 9 now. Chapter 9 is all about radicals, and in 9.1, we're going to look at radical notation and then square roots. We'll look at other kind of roots and radicals, though, in this section. Definition, it says that the square root of a given number is a number whose square is the given number. Okay, the symbol that you see here is called the radical sign, and it's used to represent the positive square root of a number. The expression underneath the radical sign is called the radicand. You'll see that terminology in the book on occasion, radical and radicand. There's a note, the square root of a negative number is not a real number. We're going to learn about the square root of a negative later on at the end of the chapter when we talk about imaginary numbers. Okay, so more on that later. But let's take a look at problem 1 is some simplifying. Okay, if I want to calculate the square root of 16, I'm looking for a number that I would need to square in order to get 16. 16 is the radicand. And, well, I know that if I square 4, I get 16. So the square root of 16 would be 4. Part B, the square root of 4/9. All right, so what number squared would give you 4/9? Well, if I square 2/3, or take 2/3 times 2/3, I get 4/9. The square root of 4/9, therefore, would be 2/3. Another way to look at it is the square root of 4 is 2, and the square root of 9 is 3, so we can split the radical. I'll talk more about splitting radicals kind of throughout this chapter here. But the square root of 0 is 0 because 0 squared is 0. The negative the square root of 64 would be negative 8. So the negative in front of the radical would have to stay in front. Okay, 8 squared is 64. So negative 8 would be the answer there. Now, the square root of negative 64 would not be a real number. In other words, there's no number that you can square that would give you negative 64. There's no number that you would square and give you a negative, period. So we would say that it's not a real number. Now, as I said earlier in the note here, we'll talk about imaginary numbers later in the chapter. At the moment, we'll just, when you see the square root of a negative, just write not a real number, okay? Negative the square root of 100. Well, the square root of 100 is 10. Since 10 squared would give you 100, the negative would have to stay in front of the radical there, so negative 10 would be my answer. Okay, now, a lot of what we're going to do in this chapter is going to be calculations without a calculator. Okay, keep that in mind when you're doing the homework. The idea is to learn the basics about radicals and to be doing the calculations without a calculator. There's several reasons why they're going to be wanting it that way, but one big reason is because we want our answers to be exact answers. Okay, we don't want to be giving decimals rounded to certain spots unless they're telling you to do that. Okay. Otherwise, you don't have the right answer, okay, because it's not exact. Another reason is because we're going to be doing several things with a variable, okay, and so a calculator is not even going to be an option if we got variables going on in the calculations there. There is a few calculator problems mixed in, not a lot, but I mean, quite honestly, probably 98% of the problems are in the chapter are going to be all intended to be without a calculator, okay. Now, most calculators can do radicals and square roots. Even the cheap $5 Walmart calculators can do that stuff. Okay, it's just figuring it out. So if I wanted to find like the square root of 7 on, here's a scientific model calculator. This is a TI-30 model, and I'll turn it to the side so you can see what I'm typing there. If I were to hit second and then x squared, it sets me up with a square root. And if I hit 7, and hit enter, it says square root of 7. Okay, now in the problem, they want us to give the decimal form of the square root of 7 to the nearest thousandths. So this calculator didn't do that. It's because of how I typed it in, okay? For this model, you want to type in a decimal in order to get a decimal in return. So if I hit the square root of 7, if I try this again, square root of 7, the square root of 7, although I'm going to say 7.0. Okay, so I've entered a decimal in, and I'll get a decimal now in return. Nearest thousandths means nearest 3 digits. Okay, and so that would be roughly 2.646 if we round to the nearest 3 digits there. On a graphing calculator, okay, such as like a TI-83 or 84 model, it'd be kind of a similar deal. You're going to hit second, and then here's the x squared button. It sets you up with the radical. You don't need to type in a decimal in this model. You just type in the number that you want, whatever the radicand is, hit enter, and you can see the number is, of course, going to be the same there if you round to the nearest 3 digits. The square root of 119, if we type that in to the nearest hundredths, okay, nearest 2 digits, that'd be 10.91 then, okay? And of course, pay attention to where they tell you to round. They'll tell you that in the problem, round to the nearest hundredth or thousandths or 3 digits or 2 digits or, whatever. Since there is rounding, of course, I want to use the approximation sign and not the equal sign. Like, this is not an exact answer, okay? I don't want to be using the equal. Actually, if I were to use the equal sign, I'd have a wrong answer then, so be careful about that. Here's a definition. Let n be greater than 1 and let n be an integer. An integer is a counting number, okay, so some counting number that is bigger than 1. If a to the n equal b, and both a and b have the same sign, then a is called the nth root of b. For notation, this is the radical form that we'd use to represent the nth root of b. The number n is called the index of the radical. Okay. There's a note here. A square root has an index of 2. We never write the 2 when we have a square root, okay, although it would be an index of 2. If the index is 3, we call that a cubed root. If the index is 4, we call it a 4th root. If it's 5, we call it a 5th root, and so on. Okay. As with square roots, an even root of a negative is not a real number. Okay, so like for example, the 6th root of negative 64, that would not be a real number because there is no number that you can raise to the 6th power that would give you negative 64. Okay, if the power is an even number, you will always get something that is not a negative. However, an odd root of a negative number, such as the cubed root of negative 64, is a real number. Okay, the cubed root of negative 64 would be negative 4, since if you cube negative 4, you would get negative 64. Like if I take negative 4 times negative 4 times negative 4, that gives me negative 64. Okay, so we got to pay attention to the index here. If we have a negative underneath the radical and determining if we have a real number or not. Okay. So let's do some more with simplifying. Okay. Problem 4, we're just going to simplify here. Part A, the cube root of 8. Okay, so I'd be looking for a number such that when I cube it, I get 8. Well, 2 cubed, 2 times 2 times 2, would give me 8. So the cube root of 8 would be 2. The cube root of 27, that'd be 3, since 3 cubed would give me 27. If I take 3 times 3 times 3, that's 27. The cube root of a negative is a negative. Okay, so the cube root of negative 27, what number would you have to raise to the 3rd power that would give you negative 27? Well, that'd be negative 3, right? Negative 3 times negative 3 times negative 3 would give you negative 27. So the cube root of negative 27 would be negative 3. How about the cube root of negative 27? Well, the cube root of negative 27 is negative 3. We just said that. If I have a negative now in front of the radical, I'd be looking at the opposite of negative 3, which would be positive 3. Now, of course, the negatives don't offset each other, okay, until you calculate the cube root of negative 27, which is negative 3. So I wouldn't want to look at it like that. But here's maybe a better example. Like, so if I had the square root of negative 27, yeah, the negatives don't cancel out, right? One's in front of the radical, one's underneath the radical. Now the fact that I've got the square root of a negative, the square root of a negative is not a real number. Okay, that's what this note was up here. The square root of a negative is not a real number. So the fact that I have a negative in front of the radical, don't worry about that. The answer is still not a real number. Okay, how about the cube root of 1/8? Will that be equal to 1/2? 1/2 cubed would give you 1/8. The cube root of 125 over 27, that'd be 5/3. Since 5/3 cubed, or 5/3 times 5/3 times 5/3 would give you 125 over 27. Another way to think about it is, okay, the cube root of 125 is 5. The cube root of 27 would be 3. Again, you could split that if, in this situation you can. You can't always split a radical, so you got to be careful about that. But here's another one. The fourth root of 81. Okay, well, 3 to the fourth would give you 81. 3 times 3 times 3 times 3 gives you 81. So the fourth root of 81 is 3. How about the fourth root of negative 81? Well, if the root is an even root of a negative number is not a real number. Okay, that should make sense here. In other words, like there's no number that you can raise to the fourth power to give you negative 81. Right? If the power is an even number, you will never get a negative. Okay, so not a real number is the answer there. Part J, the fifth root of 32. So we're looking for a number such that when we raise it to the fifth power, we'd get 32. That would be 2. 2 times 2 times 2 times 2 times 2, or 2 to the fifth, that would be 32. Okay, how about the fifth root of negative 32? Well, that'd be negative 2. Negative 2 to the fifth would give you negative 32. If the index is an odd number, it's okay to have a negative underneath, okay? Not if you have an even numbered index, though, okay? So negative 2 times negative 2 times negative 2 times negative 2 times negative 2 would give you negative 32, in other words. The fifth root of 243, that would be 3, since 3 to the fifth would give you the radicand there. 3 times 3 times 3 times 3 times 3 gives you 243. Okay, now on the next page, it says for any real number x, the square root of x squared is the absolute value of x. You may be wondering why the absolute value bars are necessary. Okay, it's necessary in order to include the negative values of x. In other words, like x can be any number here. So suppose that x is like negative 3. Okay, if I want to calculate the square root of negative 3 squared, well, negative 3 squared is 9, and the square root of 9 is 3. The square root of 9 is not negative 3, right? The square root of a number is always a positive, but x was a negative. So I don't want a negative coming out of the calculation even though x was a negative. That's the reason for the absolute value bars, okay? Although x is equal to negative 3, we do not get negative 3 from this calculation. But the absolute value of negative 3 would be 3, okay? We must use absolute value bars when dealing with variables because we do not know if the variable would be a negative. X could be any number, right? So let's take a look at problem 5. The square root of x to the sixth. Okay, we're going to do a lot of this throughout the chapter where we're going to be simplifying. And in the case of a square root, we want to look at the square root of a squared expression. Okay, because the radical that is the square root sign and the power of 2 will kind of offset each other and just give us the information that is underneath the radical that we're squaring. Okay, in this case it'd be x cubed. Now, the square root of a number is never a negative, so I want absolute value bars around x cubed. If I didn't have that, it would be a wrong answer. Okay, so again, be careful about that. Part B, the square root of 36x to the fourth. Well, I'd want to rewrite that so that I've got the square root of a squared expression. I know that 6 squared is 36, and x squared squared would give me x to the fourth. So 6x squared squared would give me 36x to the fourth. Now the square root of a squared expression would just give you that expression that you're squaring, which in this case is 6x squared. Now I've got absolute value bars, which actually for this problem, this would be a rare time where I actually wouldn't need those. There's no harm with having them, okay? But of course 6 is already a positive number, okay? And x squared will never be a negative. So 6x squared, since that's never going to be a negative, like we really don't need absolute value bars. There's no problem with having them, like we could keep them, that'd be fine, but it's also okay if we didn't have them, okay, since we're never going to have a negative coming out of the calculation anyway. Here's another one, the square root of x plus 1 squared. Okay, well that'd be the absolute value of x plus 1. Again, we must have the absolute value bars because the square root of an item is never a negative. Okay. And this one, now, I wouldn't want to make the mistake and split this into 3 radicals. Some students might want to do that. You don't want to do that. You can't split a radical unless you're multiplying or dividing the terms underneath. Okay, never ever if you're adding or subtracting. Now, x squared plus 6x plus 9 factors conveniently as x plus 3 times x plus 3, or x plus 3 squared. And that's how I'd want to look at the problem here, because the square root of a squared expression would be just that expression that is underneath the radical there, which is x plus 3. Okay, and of course I'd want an absolute value bar. Since x can be anything, I don't want a negative coming out of the calculation though. Now, there's a note here which says, for many of the problems in the book, we're actually going to assume that all the variables represent non-negative numbers. Whenever those words are stated, and they'll be saying that wording a lot, you don't need to bother with absolute value bars. Okay, like in this problem here, if I already know that x is not a negative, I don't need absolute value bars. Okay, but if they didn't tell me that, if it just said simplify, as is the case here, I would need absolute value bars. Okay, but for many of the problems, they're going to say simplify and assume that all the variables represent non-negative numbers. Again, whenever they say that in the wording, you don't need absolute value bars in the answer. Okay, we'll stop the video here.